So now we are going to continue the hinge problems, and then we are going to make the kinetic energy of a rotational motion, and then torque exerted by a rotational body. So as you know, last class you have been calculated. I think those who are absent, you might be watched videos. Am I right, everybody? Manya and Samya, others, Sudreswa, you already know. So we all know. We have seen many questions like calculating the hinge force. So wherever hinge also we can call it as what? The pivoted point only we used to call it as what, everybody? The pivot point which is only we used to call it as hinge. So at the hinge, calculating the normal reaction. So normal reactions will act in how many directions? Two different directions. So you can take one is N1, another one is what, everybody? Another one is N2. So now, so we have seen a rectangular glass rod has been placed, different things like hinges present at the one of the corner, or we have seen a rectangular glass rod where hinge are pivoted at the middle, center. Like this, different things we have calculated. Am I right, everybody? We have calculated what is angular acceleration and what we have found, everybody. Angular acceleration. Then we have found acceleration of COM. So at the COM, center of mass, two accelerations will act. One is towards the center, that is what we used to call as centripetal acceleration.
Tangential.
Tangential acceleration. And then the third one we have found that reaction force offered by the hinge. That is what we have been done. Reaction force offered by hinge. So these are the things we have been calculated. So now let us take, instead of glass rod, instead of rod, rectangular rod. So now we are going to take a 3 equal mass has been kept on a horizontal table. So imagine in front of you, there will be a table. So I have been giving you 3 masses. Do you understand, everyone? So like imagination. So imagine there will be a table. So where 3 masses, equal masses has been placed. Just for your purpose, I am drawing. 3 equal masses placed from the equal distance. Means equal distance means they will be attached into what, guys? Equilateral triangle. Understand, Dreswa? Now the first triangle, let me take, this is A and this is B and this is C. So has been pivoted at the A point. Has been pivoted at the A point. Brothers, can you able to understand a hinge? So now imagine like here I have been fixed the screw. Now this is the angular rotation. So that these bodies are keep on rotating around this. Do you understand our Dreswa? Like this, it is axis of rotation. So this is what is our hinge point or pivot point. So these bodies are moving with a constant omega. What do you mean by omega, everybody? Angular? Yeah, angular velocity. So angular velocity is constant. So that is what is the question. So now 3 masses is equal. So the length between them is equilateral triangle. So length is what, everybody? Equal. Yes or no? All of you? So that is what just I'm saying you. So it has been placed on the horizontal table and it has been connected with a massless rod. That is what you have to write it. So please write it. 3 masses of equal mass, 3 equal masses has been placed on the horizontal table and they have been connected with the what body, everybody? Massless rope. That is what a rigid body. So massless rigid rod or thread, you can take it. Rigid body has been connected. Okay, connected by 3 bodies. So that is what you have to remember it. So that what we can take, everybody. So let me draw the equilateral triangle so that you all can understand. So it has been kept with the equal distance. That is very important. So equal distance means we all knows that. Every time, what is that, everybody? L is remains constant. Am I right or wrong? Distance between any two bodies. Yes or no, guys? Please respect. That is what. So let me take here. Now observe. I will take a 3 different bodies has been having a same mass. One body has been kept here who is having a mass m. Another body has been kept here whose mass is another mass m and mass is m. So this is what is our pivot point. This is pivot point, and they have been moving with the what? Constant angular velocity. Angular velocity is remains. Yes, please. Remains constant. Now, all of you check it. So, what is our question means? Find the not angular acceleration and all. Just find the hinge force. That is what they are asking. So, we all people knows that hinge forces. How many it will act? Everybody. Hinge forces, pivoted point it will act. So now how many different directions it will act? One is upper directions. Let me take N1, and another one is horizontal direction. That is what it is. What is it, brothers? Yes, N2. Clear everybody? Now, before going to make the solve the question, they are asking find the hinge force. So before understanding the question, you should see they are mentioning the question constant angular velocity. So velocity remains constant, no change in velocity. So no change in angular velocity, something is zero. Can you tell me what is zero? Rate of change of velocity is zero. So acceleration is what?
Angular
Velocity changing
acceleration.
zero. So acceleration is zero. Here angular velocity is not changing. So that angular acceleration will become what? Everybody. Angular acceleration becomes zero. If angular acceleration becomes zero, then tau will become what? Everybody?
Zero.
Tau will become what? Please respond. Zero. Now, so we all know, so we have to find the center of mass now. So for an equilateral triangle, center of mass is existed between them. Am I right, everybody? Equilateral triangle, please respond, all of you. So let's first let me complete that. So you how many you all studied in 10th class mathematics also? So equilateral triangle, we all knows that. How to find center of mass? We can extend it. I will say that. You all should learn it. So from the equilateral, yes. Equilateral triangle means it is what, Rudreswar, it is 60 degrees. Am I right? Each angle is 60 degrees. So if I make it, then it will be wherever that, if you extend it towards to that, so wherever it is meeting, that point is we used to call something. What is that called as, all of you? The intersecting point of that is only we used to call as what? Everybody. That is only we can say center of mass. Correct or not? In mathematics, something we used to call. Anybody can tell what is that called as? Yes, please. Rose? Anyhow, let me see. This is equilateral triangle. So this is only called as COM, center of mass. Am I right, Rudreswar? Yes?
Yes, sir.
So three bodies are there. This body mass is M, and this body mass is M, and this body mass is M. So center of mass means whole mass is existed. So at the center of mass, what is the total mass? Can you tell me? M and M and M. Total mass is how much? Everybody. At the center of mass, what is the total mass? Everybody? 3M. Understanding? So now you can see in mathematics, this point we used to call as basically is not center of mass, we used to call as centroid. So now centroid actually we will represent with the G. So now centroid will divide this height. Height of the triangle will divide in two different ratios. Can you tell me what is that? 10th class, if you remember, you can tell. So it is the height of the triangle. So height of the triangle.
Sir, 2:1.
Yes, very good, Rudreswar. Do you remember 10th class? I think you studied that, correct?
Yes, sir.
Yes. So it will divide with what ratio? Brothers, remember? See, that is what it is connected.
Sir, 2:2.
So it will divide with what ratio? Everybody, girls? It will divide with the 2:1 ratio. So that is what. So this total height is H means, so it will divide with the 2:1. So totally how many parts, everybody? How many parts? 3 parts it is. Correct, ma? Please respond, everybody. So that is what it is. Now, so at the center of mass, you can see, so if you imagine a whole body is revolving, so it will be started making rotation. So here two forces are acting, center of mass, two accelerations. One is tangential acceleration and one is towards to the pivot point. What is that acting? Everybody. Yes, please. Centripetal acceleration. Are you clear? Here is the pivot point. So this is centripetal acceleration and this is the what? Tangential acceleration. Now, so two accelerations at COM. So tangential acceleration formula, tell me, everybody. Tangential acceleration formula, R into alpha. Centripetal acceleration formula, R into omega square. Are you clear, everybody? Please respond, guys. That is what? Now we all know that angular acceleration is 0. So tangential acceleration will become what? Everybody? Alpha is 0. So tangential acceleration become what? 0. So before cases, when we are solving the rod case, have you checked it? Centripetal acceleration becomes 0. Now which acceleration becomes 0 in the case of triangle? Everybody? Yes, please. Tangential
Tangent.
acceleration becomes 0. Now, what about centripetal acceleration? So centripetal acceleration r omega square. So let us find it. So now we all people knows as it is acting towards to the center. So we have to find it. What is this r? R means what? Distance between the center of mass to the hinge pivot point. Am I right or wrong? Everybody, please respond, guys. Yes or no? So we need to
Yes,
know
sir.
that. So how to find the r? Let us see. So this total height is h means this remain only this distance is what actually r. So we want to find that one. So as it is divides with the 2:1 ratio. So let us see. We all people knows that. So triangle. So here is the 60 degrees means. So we all people know. Imagine like. So this is the resultant force. Then this and this. Now here is the 60 degrees. Actually triangle it is. So 60 degrees means here what will come? L cos 60 and opposite what will come? Everybody. L
Sin 60.
L sin 60. So I'm imagining parallel shift. I'm imagining parallel shift now. So here what will become? This will become what? Everybody. Height of the triangle. Rudreswa. L sin L sin 60. Are you clear, everybody? So height of the triangle is L sin 60. I hope everybody understanding. Clear, Amma? Girls?
Yes.
Yeah. So that is what it is. So L into sin 60 value, how much? Everybody, that is what the height of the triangle. So H is equals to L sin 60. So what is the sin 60 value? Everybody?
Root 3 by
Root 3 by
Root
2.
3 by 2. So that is the total height. So the total height I got L into root 3 by 2. But we want it what? How many parts? This part is one part and this part is two parts. So how to find that R? R is equals to, what will happen, everybody? L into root 3 by 2. How many parts it is? 2
into
by 3 parts. 2 by 3 parts. Total number of parts is 3 parts. So this part I want to find it means 2 by 3 parts. Right or wrong? Everybody?
yes, sir.
Yes. So
Yes,
2
sir.
will get cancel, which is equals to, R is equals to what? L root 3 by 3. So I'll multiply both numerator and denominator with the root 3. So up will become what? Everybody. Up it will become
L by
L
root
3
3.
by 3 root 3. So 3 will get cancel. What is the R value? Everyone? R value is? Yes, please. L by root 3. So
By root 3.
centripetal acceleration is equals to L by root 3 into omega square. That is what it is through the center of mass. Now we want to find N1 and N2. So let us find it now. So very simple. So first N2, N1, which one you want it, you can find. So at the center of mass, so two accelerations. One is tangential acceleration and another one is what, everybody? Centripetal acceleration. So this is N1,
Centripetal
this is N2. So tangential acceleration is 0. So that N2 also will become what? Everybody? Tangential acceleration becomes 0. N2 also will become what? 0. Because normal reaction. So what is the force formula? Force is equals to mass into acceleration. So here mass is how much, guys? At COM, what is the mass? I already told you. At the center of mass, what is the mass? Total mass?
3M.
3m. So N2 is equals to 3m into 80. So 80 is 0. So N2 will become what? Everybody? N2 will become what? 0.
0.
Now N1 and centripetal acceleration. What is the centripetal acceleration? L by root 3 into omega square. L by root 3 into omega square. So N1 is equals to mass into acceleration, centripetal acceleration. So mass become 3m. Centripetal acceleration is L by root 3 omega square. L by root 3 omega square. So both numerator and denominator I will multiply with the what? Everybody? Yes, please. I will multiply with the root 3 by root 3. Okay, so which will turns into 3 root 3 ml omega square divided by root 3 whole square. So this 3 and 3 will get cancelled. What is the answer? Root 3 ml omega square. So N1 is equals to root 3 ml omega square and N2 is what? Everybody? N2 is equals to how much, guys?
0.
0. Okay. So that is what you have to solve it. Say if you are practicing only, it will be. So very simple it is. So mathematics concept is very important, and parallel shift also. So we all people knows that. All of you observe very carefully. So this is actually what everybody L. So if here is the 60 degrees means, so we all people knows this will become what? Everybody L cos 60, and perpendicularly what will happen everyone? This will become what? L, please respond. L sin 60. Correct or not? This L sin 60 only parallel shift. So if this is L sin 60, then this also will become what? L sin 60. So that is the total height. Total height is equals to L sin 60. But we all knows that centroid will divide with what ratio? Everybody, 2:1 ratio.
2:1.
The total parts is, because we want only from the centroid or this alone. So 2 parts divided by total parts into H. So H is what? L sin 60. So if we do that, you will get the R value. Are you clear, everybody? I hope everybody understanding. So which will give you R value so that you can find it. So here, whose acceleration is 0? Tangential acceleration or centripetal acceleration?
Tangential acceleration.
Tangential acceleration is 0. Clear, everybody? Anything doubt, you can ask me. Mr. Kadir, understand? Rohit, Rishi, Murali?
Yes, sir. Yes, sir.
You have to solve. If you are not solving, there is no use. Mr. Narayan, understand, Narayan?
Yes, sir.
Put efforts. If you put efforts only, you can be. If not, it is very tough. So the same question, I will make a small modifications. So you can see that what will happen means, imagine you are rotating one time. So whenever these bodies will take rotation and coming back to the original position, by the time I applied some F external force on BC axis. So I assume this body is what? A body, this body is B body, and this body is C body. So the next question is, I applied some external force B, at the BC axis, when after making back into the same position, like rotation after time t. So it is keep on revolving. So now after certain time period t, a horizontal force is applied on BC. So which is like BC means what? Which is parallel to x-axis or parallel to y-axis? BC. BC is parallel to x-axis or y-axis? Everybody? BC is parallel to x-axis. Are you clear? So that is what it is. So now I am applying certain force after the certain time period. So you can take it now. So here is the one body, that is what pivoted point A, and here is another mass, here is the another mass. So after certain time, write the question. Same it is. Same question, just we are adding. So after time t, a horizontal force F is applied. F is applied on BC. So this is A, this is B, and this is C. On BC, that is what? BC parallel to x-axis. Find hinge forces. Just when F is applied. When F is applied. So that is the question. So just try, everybody. Whatever you can do it. Just try, all of you. Are you clear? Understand, Amma? Yes, please.
Yes, sir.
So at the center of mass, again same thing. So center of mass, two forces, two accelerations are acting. What is that? One is tangential acceleration. Another one is what acceleration? Everybody?
Centripetal.
Yeah.
Centripetal.
Tangential acceleration. So now what is the question? After certain time means it is keep on rotating. So after certain time, so once this position will came, there some external force is applied on the B axis. So that is the question. BC axis, which is parallel to the whom? Everybody. Parallel to the x-axis. Clear, everybody?
Yes.
BC is parallel to x-axis. Now, so we all knows that. What is the height of the triangle? Height of the triangle. What is the formula? We have been found already. What is the height of the triangle, everybody? H is equals to L root 3 divided by what? Please
2.
respond. 2. So now you can see, after certain time, they are asking us what is the find the hinge forces just where applied. So now we all know, so we first we want to find the angular acceleration if you want to find that and all. So now you can see that as it is equilateral triangle. So all the sides it is L. So now what is the tau formula? Tau is equals to what, everybody? I into
alpha.
yes or no? So now alpha. Now this is actually is our pivoted point. So from the pivot point, it is present some same L distance and L distance. So can you tell me what is the momentum of this body and this body from this, everybody? What is the total momentum? Yes, Mr. Dresa, it is R distance and R distance both. So what will happen? Both bodies. This will become ML square plus ML square into alpha. So what is the total tau? Tau is equals to how much, guys? Force is applied. So tau is equals to what will happen?
2ml square.
ML square into alpha. So that is what it will become. So we all know another formula. Tau is equals to what? Force is applied now. R into F. So what is R, guys? Here is the force applied from the pivoted point. So what is the R? R is equals to something. Everybody, check it here. Pivoted point here and force is applied here. So what is that R? R is equals to something. What is that, guys? H. That's all it is. So tau is equals to, we have found it, 2ml square alpha. R value how much, guys? L root 3 by, that is what, H. R is equals to L root 3 by 2 into F. Now, L will get cancelled. So what else is remaining? Everybody check it. So alpha is equals to root 3F divided by 2 2s are 4ml. So this is what is the angular acceleration when after applying the force F. Are you clear, everybody? Please respond, everyone. Understanding? So that is what it is. Now why tangential acceleration is not 0? Is it now tangential acceleration 0 or not 0? Anybody? Tangential acceleration 0 or not 0? It is not 0. Why? The force is applied now. So it is not 0. So what is that, everybody? So at the center of mass. So we all people knows that. At the center of mass. So we are having two forces. One is tangential acceleration R alpha. And this one, centripetal acceleration. What is the formula? Everybody. R
Omega square.
So at the COM, what is the total mass, guys? At the COM, what is the total mass? Everybody. At the COM, what is the total mass? 3m. Correct or not? Everybody. So now you can notice it. So there is a two forces, hinge forces, N1 and as well as N2 now. So we want to find N1 and N2. Let us find first N1. So N1 already we know. How much are those? N1. So 3ml omega square. So that is what is N1. Am I right or wrong? Everybody? 3ml omega square. Now N2. Now N2 is 0 or not 0? Before force is not applied. So that tangential acceleration 0, N2 is 0. Now N2 is 0 or not 0?
Not 0.
Not 0. That is
Not
you have to be very careful. Are you clear, everybody? Now we have to find it. So tangential acceleration is not 0. So that what is the formula for tangential acceleration? Mass is, that is what? So 3m mass and applied force is in this direction. So what is the tangential acceleration? R alpha. So what is R alpha? R value how much? Everybody. L by R value how much, Ra? Yes, please. Tangential acceleration, R values.
L by root 3.
Yes, please. From this R value, how much Ra? We have been found it correct. Huh? L by
Root 3.
Root 3.
so L by root 3 is the R value into what is the alpha value? Just now we have found alpha. What is alpha? Root 3
Root 3
F divided
by
by
4
Root
m.
3 by
okay.
4m.
That is what. So root 3 F divided by 4 ml. So LL will get cancelled. Root 3 will get cancelled. So what is the tangential acceleration equals to? Everybody. F
By
divided
4
by
m.
F by ml.
ml or 4 ml.
4 ml, sir.
That is what. Now you can see. So N2 is also acting in the same direction and force also applied in the what? Force also applied in the same direction.
Same
So
direction.
means in the sense of what? F plus N2 which is equals to mass into centripetal acceleration. So mass is how much Ra? 3m. Centripetal acceleration is F by 4m. F by 4m. So mm will get cancelled. So what is the answer? Everybody. F plus N2 is equals to 3F divided by M. So N2 is equals to 3F divided by 4 minus F, which is equals to 3F minus 4F divided by 4. So what will happen, everybody? Yes, please. N2 is equals to minus F divided by, yes? What is the answer? Minus F divided.
Minus F by 4.
Clear, everyone? So that is what. Now here what you understanding? When external force is applied, so the tangential acceleration 0 or not 0? Tangential acceleration is not 0. Why? Anybody can tell me? When external force is applied, omega remains constant or varies?
Very.
External force is applied. Omega is not constant. So that omega is not constant means angular acceleration is not 0. Do you understand, brothers? So that is why first you have to find the angular acceleration. And then centripetal acceleration remains constant. So centripetal acceleration r omega square. So n1 is remains same, root 3 ml omega square. So n2 only minus f by 4 it will come. So that is what it is. Narayan, understand, Narayan? For those, Rudreswa, clear? So this is what is about the hinge forces. Hinge forces, one of the most important concept for JEE and as well as NEET. So it will be very, very, see, this whole chapter is important only. Every concept is important for NEET and JEE. The most toughest chapter for many people. Many people will face difficulties in this chapter. That is why we are spending this much time. So kindly understand and make it. Are you clear, everybody? Almost over now. 70% chapter is almost completed. Now remaining, we are going to study now itself kinetic energy of a rotating body and then work done by the torque of a rotating body. These two concepts over, then related to that some numericals, and directly then we'll go to the next concept. So till here you solve it. Anybody having doubt, you can ask me. I hope you all understand. Mr. Kadir, Rudreswa, are you clear?
Yes, sir.
Yes. So solve it. Are you clear, everybody?
Yes, sir.
Yes, sir.
So if you are if you understand this, then you can proceed. So then we can keep a heading. Okay. So next, right? Everybody, kinetic energy of a rotating body, work done by a torque. This you complete it. If you complete it only, then we'll proceed further. Anything doubt? Anybody can ask. Have you completed everybody? Yes. So
Yes,
the next
sir.
concept, very important concept is kinetic energy. So we already studied kinetic energy actually. So kinetic energy of a, now we are going to study for rotating body. So let us see now kinetic energy of a rotating body, how it will be. And even we are going to study proof also now. So we all know when the body is traveling, suppose imagine if any kind of body is traveling with some velocity v. So what is the kinetic energy formula? Everybody, kinetic energy formula is what? Half m
V square.
V square.
But now we are going to study rotating body. So it is not normal body, it is the rotating body. So that what will happen? Kinetic energy. So kinetic energy, you can take EK. So kinetic energy is equals to half into. So in motion, what will happen, guys? This is a straight line or plane motion. Now circular motion, rotational motion, M will replace it with a what? Something. Anybody? Moment of inertia, and velocity is replaced with the angular velocity. That is what square. So this is the kinetic energy formula of rotating body. So please write it. Kinetic energy formula of a rotating body is half into I into omega square. Clear everyone? So mass is replaced by moment of inertia and velocity is replaced by angular velocity. I hope everybody understand. Any doubt? Anybody can let me. Clear everybody? Narayan?
Yes, sir.
So now you can notice it. All of you observe very carefully. Let us make the proof now. So we all discuss it. If you make the proof, it will be clear. First derivation is only very important. So because understanding is very needed. Okay. So now let us see that. So let me take some rigid body. So some random body, I will take it. Okay, so where it has been pivoted, this is the point where it has been pivoted. Just everybody have a make it. So now I am choosing a some mass of having total mass is what everybody, this is a rigid body. Total mass is what? M. So I am choosing a particular mass, M1 mass. So where the particle having a velocity v1 velocity. Okay, so which is actually revolving around this particular point. Imagine this whole body is revolving around this particular point. Clear? Having angular velocity omega. So what is the distance between the pivoted point to this point? Let me take this as a r1. Are you clear, everybody? Understand, Amma?
Yes, sir.
Yes. So generally, I want to know the kinetic energy of this first particle. So what is the kinetic energy of the first particle? Let me take Ke1, which is equals to what will happen? Half into M1 into V1 square. Okay, Rudreswa?
Yes, sir.
Yes. So now let us see. Let me take another particle, which is some other R2 distance from that. Let me take that mass is M2, whose actually this all the particles are going in a particular direction. That's what revolving around this pivoted point, whose velocity is V2. And from the distance from the pivoted point, let me take it as a what? Everybody, R2. So can you tell me what is the kinetic energy of this particle? Kinetic energy of this particle is equals to what? Half into, everybody, M into, please respond. M into V2 square. Clear? Yes, all of you. So like that, I will take n number of particles. I'm having n number of particles in that. So kinetic energy of a nth particle. What will happen? Kinetic energy of a nth particle. Half into mn into vn square. Understood or not? You should say only correct. I will understand. Clear, everybody? That is what. So now I want to find the total kinetic energy. So what is the total kinetic energy? Anybody? So total kinetic energy is equals to, respond, everybody. Yes, please. Half in the sum of the individual energies. That is what? K1 plus K2 plus and so on plus Kn and
K1.
yeah, Ken. That is what it is the formula. So now K1, what is the kinetic energy of a particle? M1 V1 square plus
M1 V1
second
square.
one K
Half M
half
V2
Mn
square.
V2 square plus and so on. So on. What will happen, everybody? Half Mn Vn square.
Vn square.
Of course, the particles having different velocities, but you see that they are revolving in a circular motion. So that remains constant. Velocity may vary, something remains constant. Everybody? Every particle, what remains constant? Angular velocity remains. Yes, angular velocity remains what? Everybody? Remains constant. So what is the V1 formula? V1 is equals to what? We all knows that V is equals to what is the formula? R into omega. Am I right or wrong? Everybody? Yes, please.
Yes, sir.
Yes. So S is equals to R theta. Acceleration is equals to R alpha. And V is equals to R omega. So now V1 is equals to what is the formula? Everybody? R1 into omega. V2 is equals to what is the formula? R2 into omega. Like that, if I take Vn,